A topic that is often a source of difficulty for people early in the course has to do with translations of functions. So in this video, we're going to look at some examples of horizontal and vertical shifts, and in other videos, we will get to the other types of translations. Now, as far as what we're expecting from you, you can get a feel for this from looking at the text, looking at the assignments on MyLab, and looking at the mock exam. Basically, we want you to know it when you see it. And so in this video, we want to talk about a few things that you should look for when you're confronted by a graph and you're wondering what's happened here. What am I supposed to see? Now in this video, and in the other ones that are related to this, I'm going to be using the letter C to represent a constant or a number. And in order to avoid having to qualify everything that I say, I'm going to assume that it's a positive constant or positive number. Now I don't know if you know, but it's easier to talk about this if you have a little bit of vocabulary, so I'm not trying to be pedantic, but when you look at the notation that we use for a function, f of x, the x, in other words, the content of the parentheses that are right next to the f, the x is the argument of the function. The content of the parentheses is the argument of the function. And so what we're saying here is that if you want to pull off a horizontal shift, what you want to do is you want to add or subtract a constant from inside the argument. Now, one thing that causes some confusion is that it's contrary to intuition. So in other words, when most people picture the number line, they picture the negative numbers being on the left and the positive numbers being on the right. And so for that reason, when they look at horizontal shifts, if you just ask them and they don't actually know, most people will assume that subtracting moves the function to the left and adding moves it to the right, but it's exactly the opposite, as you can read here. It's not a typo. And so I would encourage you, if you want to take a look at some particular examples in your calculator, you can do that and you can convince yourself that this is the case. But anyway, you have to remember, subtracting a positive constant actually shifts the function to the right horizontally, and adding a positive constant inside the argument shifts the function to the left. Let's look at an example. When I talk about using your calculator, here's what I'm referring to. You can look at your own examples using your own calculator. So as you can see, I have a function that's been translated horizontally here. So the original function is going to graph in blue, and that's y sub 1. And it's the function f of x is x squared. And then I have a horizontal translation, which is going to graph in red, and that's y sub 2. And as you can see, I'm subtracting 2 inside the argument. What's that going to do? Well, it's like we said, if you take away a positive constant inside the argument, you're actually shifting the function to the right. And so you're going to see the graph in red appear 2 units to the right of the graph in blue. Likewise, in y sub 3, which is going to graph in black, we're adding 4 inside the argument of the function, and that means that we're going to be shifting it 4 units to the left. And so you'll see the graph in black 4 units to the left of the graph in blue. Take a look. There's the original function. There it is translated 2 units right, and there it is translated 4 units left. And so you can do that kind of a thing with your own calculator. I just want to kind of set the stage, give you some ideas maybe. But typically this is not how we would be asking this kind of a problem on an exam because, well, to be direct, you can answer it without really knowing anything. I mean, you can just graph it and see, oh, it's shifted 2 units to the right or 4 units to the left, whatever. We're more interested in having you read something that we've provided. Like, for example, this example here comes closer to illustrating what we really want from you. We want to be able to give you a graph, as you see on the left, a function, f of x, and we're going to give you what you see on the right, but without the answer right below the graph. And so we want you to notice a few things that are going to enable you to answer this kind of a thing fairly easily. Now we're using these piecewise functions because they have a domain which has a finite length, and likewise a range which has a finite length. If you do this kind of a thing with functions that are not supported in that way, it's much harder to read what's actually going on. And so by using these piecewise functions, it actually makes it much easier for us to teach this. So take a look at the function f of x on the left. We want you to notice how long is the domain of that function and how long is the range of that function. So the domain is where the function lives on the x-axis, and if you're looking at the graph on the left, it should be visible that the function goes from -8 to +8. And so the domain is 16 units long. And really, if you're looking at a horizontal shift, it's the domain you want to pay attention to. And so I'm looking at the graph on the right, and I can see, okay, the graph is still, it's still supported over a length of 16 units. And so that's important because it tells me that nothing else has really happened. I mean, it's been moved around. But notice, the function on the left is increasing and then decreasing and then increasing. So in other words, it's increasing here, and then it's decreasing, and then it's increasing again. And the function on the right exhibits the same behavior. It's increasing, decreasing, and increasing. And so that suggests to us that it hasn't been reflected. And that's important as well. And when we look at the range on this function on the left goes from -4 down here to +4 right here. And so the range has a length of 8. And when I look at the other graph, it also has a range that covers 8 units on the y-axis. And so by a process of elimination, I can look at this graph on the right, and because the length of the domain hasn't changed, the length of the range hasn't changed, and the behavior hasn't changed in terms of increasing and decreasing. It's still doing the same thing effectively. I'm looking at that and I'm thinking, okay, that's a horizontal translation. Now, as far as what the translation is, it's important to know that horizontal translations always apply equally to every point on the graph. Likewise, vertical, because we're not compressing or expanding. And so everything gets moved the same. But most people would tend to fixate on some of the extrema or the other features, if you will. So for example, we have a local maximum here at -4 on the x-axis, and we have a local minimum over here at +4 on the x-axis. And the relative positions of those has changed. You'll notice that we were at -4, and now we have a maximum at -1. And likewise over here, we have a maximum or minimum at +7. And so you can see that both of those have shifted 3 units to the right. And if you look at other features of the function, for example, I would describe this as sort of the center, if you will. You can see that the original graph passes through the origin, and if you look at it, there is a symmetry, if you will. And so I can see over here that the center has been shifted to +3 on the x-axis. And so all of those things are telling me the same thing. They're saying, hey, this is a horizontal shift, and the function has been shifted 3 units to the right. Look at another example. Now again, I'm looking at this, and I look at the original function on the left, and I'm comparing with it the other function on the right. And normally, if we were asking you this kind of a question on a test or on a quiz, whatever, we're not going to obviously include the answer as part of the graph, but anyway. So again, I'm kind of running through a mental checklist here to see, well, what am I looking at? And so I look at the length of the domain and the length of the range. And so as before, that hasn't changed. The original function had a domain that was 16 units long, and the other one does as well. The original function had a range that was 8 units long, and the other graph does as well. And so that rules out any kind of a expansion or compression. And then I'm starting to look at some of the features. So again, on the left, the function increases from -8 on the x-axis to -4, and it's also increasing from 4 to 8. And over here it does the same. Well, it increases, but at a different location. So here it's increasing from -10 to -6, and from 2 to 6. And the center of the function, which was at the origin, looks to be over here at -2. And the extrema have also been shifted the same number of units. In fact, any point on the graph, if you pick and look, it's been shifted the same number of units. And so again, that tells me, okay, this one has been shifted 2 units to the left. And so that's why the answer would be y is f of quantity x plus 2. Let's look at another example. Now, when it comes to vertical shifts, We're still using the letter C. We're still assuming it's a positive constant. But notice the subtraction is taking place outside of the argument. And so in that case, everything works as your intuition would suggest. Negative shifts things down. Positive shifts things up. Take a look. Original function on the left, translated function on the right. And we've seen the original function on the left a couple of times. Take a close look at the graph of the one on the right and see if you can recognize that this is a shift of 4 units down. Again, compare the domain, compare the range, compare the features, and it's pretty obvious that any point you pick on the original graph of f has been shifted 4 units down. And so this would be y equals f of x minus 4. Look at another. Original function on the left, translated function on the right, and again, compare domain, range, features, where is it increasing, where is it decreasing, and you can see that the center or the extrema, whatever you want to fixate on, they've all been translated the same number of units. They've been shifted 3 units up. And so that is a vertical shift by 3 units. Now we have some other examples that are similar and a little bit more challenging on the mock exam. And so I would definitely encourage you to look at that. But we also have some additional videos on this that cover other types of translations, other types of reflections, and so on. If you have any questions about this particular video, feel free to drop me a line. Otherwise, take a look at the next one.